Okay, so today we are starting our unit on logic and reasoning. Logic and reasoning is super important. It helps you think through a lot of different things so you can process thoughts and strategies and things. It'll help you in more than just math. So you're not going to be doing much math today. You are going to be doing a lot of writing. So get ready for that. All right, so we're starting out with conditional statements. A conditional statement is a logical statement with two parts. It's written in the form if then. And then it's noted by P arrow Q. So basically what you have is it's going to say if something, then something, kind of like cause and effect. So if P, then Q. So this part, we're going to underline the hypothesis and circle the conclusion in these statements. The hypothesis is the P portion of your statement. So this is your hypothesis. And I need a smaller pen. And then the Q part is your conclusion. This is what comes after the then. So if a hypothesis, then a conclusion. Let me make this a little skinnier. Okay. All right, so what we're going to do is we're going to underline the hypothesis and we're going to circle the conclusion. So if an angle measures 30 degrees, then it is an acute angle. So an angle measures 30 degrees is the hypothesis. Then it is an acute angle is our conclusion. The words if and then are not part of the hypothesis and the conclusion. They just tell you where the hypothesis and the conclusion are. So if two angles are adjacent, then they have a common side. So two angles are adjacent comes after the word if, then the conclusion, they have a common side. If two lines intersect, then they form a right angle. So two lines intersect, they form a right angle. Now, think about this for just a second. Are all of these true? Or when you read one, did you go, that's not right? If an angle is 30 degrees, then it's acute. True or false? Well, that would be true. If two angles are adjacent, they have a common side. That would be true also. We did that yesterday. If two lines intersect, they form a right angle. That is false. Not all lines are perpendicular. Some of them just cross like this. All right, so now you can take a statement and you can convert it into if then. So for example, if I said all even numbers are divisible by 2, how could you write it so that it would say if blah blah blah, then blah blah blah? All even numbers are divisible by 2. If a number is even, then it is divisible by 2. What about you are in Texas? If you are in Houston. So see how it says if you are in Houston? It's telling you the P portion of your statement. So I would say if you are in Houston, then you are in Texas. So would this first one be true? If a number is even, it's divisible by 2. That would be true. If you're in Houston, are you in Texas? That would be true. What if it said, if you are in Texas, then you are in Houston? Then it would be a false statement. So see how the wording will change the value of your statement? All right, so with that being said, let's talk about the negation. The negation is when you say the opposite. So like the opposite of 1 is -1. That's the negation. So if my hypothesis is P, then not P, the symbol equals the word not. I call it squiggly. So if I say squiggly P, then that means the opposite of P. So for an example, write the negation of the statement. Well, where did my statement go? There it is. All right. So write the negation. An angle is a right angle. Well, what's the opposite of an angle is a right angle? An angle is not a right angle. So all you have to do is use the word not when you see this symbol. Okay, so what we're going to do is we're going to write some sentences. Our original sentence is going to be if P, then Q. So this is if P, then Q. And then we're going to determine if it's true or false. So they're telling me that the hypothesis is you are a guitar player. They're telling me my conclusion is you are a musician. So I would say if you are a guitar player, then you are a musician. So if you are a guitar player, then you are a musician. So we'll give you a chance to get that copied down. There we go. So if you are a guitar player, then you are a musician. Is that true or false? So if I play the guitar, am I a musician? Absolutely. All right, now we have something called the converse. No, it's not your shoes. So what you're going to do is you're going to switch the hypothesis and the conclusion. You know how like I just did, if you are in Houston, then you are in Texas, and that was true. But then when I said it backwards, it wasn't true anymore. That was the converse. So now I'm going to switch this. Instead of saying, if you are a guitar player, then you are a musician, I'm going to say, if you are a musician, then you are a guitar player. So if you are a musician, then you are a guitar player. And I will give you a second to get that down. And now the symbols flip. So instead of the way we had it up here, if P, then Q, now it's going to be if Q, then P. Now is it true? If you are a musician, then you are a guitar player. No, that would be false. Why is that false? Because the guitar is not the only musical instrument. You could play anything else. Okay, the next form is called the inverse, and you do need to remember these, okay? So you need to remember if P, then Q, if Q, then P, and you need to remember which one they belong to. Are they converse, are they inverse, or are they contrapositive? So the inverse is the conditional statement. See how it's just like the conditional P, then Q, except it has the not. So not P, then not Q. So now I'm going to say, if you are not a guitar player, then you are not a musician. So would that be true or false? So if I don't play the guitar, does that mean I'm not a musician? Well, that would be false. Why would it be false? Well, it would be false because just because I don't play the guitar doesn't mean I don't play something else. And then your last one is called the contrapositive. That's where you take the converse, the Q, then P, and you make both of those say not. So now we're going to say, if you are not a musician, then you are not a guitar player. So would that be true or false? Well, if you're not a musician, then, well, if I'm not a musician, then I don't play anything at all. So this one is going to be true. So if you are not a musician, then you are not a guitar player. All right, so now, if you'll notice, when you're looking at these, notice how the conditional statement and the contrapositive are the same. They're both true. They're called logically equivalent. That means that you're saying the same thing, you're just changing the words up. You see this a lot with advertising agencies. They will switch words up. Like when you're walking through the mall and you see the big sign that says free phone, and then in real tiny print, if you sign your life away. So that's an if then statement. They're saying, if you sign this 5-year contract, then you get a free phone. But they're advertising the conclusion because the conclusion is better than the hypothesis. And then the same thing for the converse and the inverse. They're both false. They're logically equivalent. So you're saying the same thing, but in a different way. Another job where this is super handy would be an attorney. if you have really good logic and reasoning skills, that's one of the things that can make you a really great attorney. So equivalent statements are when two statements are both true or both false. So on the previous page, it said which statements on the chart were from page 1 are equivalent. So we know that the conditional and the contrapositive, they were both true, and the converse and the inverse were both false. So both of these, let me go back up here, both of these were true, and in this case, both of these were false. All right, so now what we're going to do is we are going to look and see whether each statement about the diagram is true, and we're going to explain using the definition that one of the definitions that we've learned. So let's look. So it says decide whether each statement is true. All right, so line AC is perpendicular to line BD. So line AC is perpendicular to line BD. Well, this would be true. And then it says explain using the definition you have learned. Well, if two lines intersect and they form a right angle, then they are perpendicular. So maybe say if two lines intersect to form a right angle, then they are perpendicular. And I'm just going to use symbols for this. And how do I know that they're perpendicular? Because there's the right angle mark. So there is a right angle mark. So that's how I know, by looking at the picture. My eyes see the box and I know that's a right angle automatically. Okay, what about angle AEB? So AEB is this angle with the right angle box. And CEB, which would be this side over here, are a linear pair. Yes, this is true. This is true because angle AEB plus angle CEB equal 180 degrees, because if this is 90 and we know this is 90, and we know that A, E, and C are collinear, so these are things that you get from the picture when you look at it. These are what help you solve your geometry problems. And I also know that AE plus EC equals AC. And then the last one says ray EA. So ray EA, so EA is going this way, and ray EB are opposite rays. This is false. They're not opposite rays because one is going to the left and one is pointing up. To be opposite, they'd have to be collinear. So ray EA and ray EC are opposite rays. Okay, this is why I always type this stuff in. This is terrible handwriting. All right, next. Biconditional statements is when your conditional and converse are both true. So like if we were to go back to here, the conditional was true, but the converse was false. This is not a biconditional because they would both have to be true. So when they're both true, then that makes all of them true. And instead of saying two separate statements, you just say a single statement and you use if and only if. And it's denoted with P, arrow back and forth, Q, meaning If I go this way, it's true, and if I read it this way, it's true. So for example, if two lines intersect to form a right angle, then they are perpendicular lines. So here is our hypothesis. Here is our conclusion. Okay, and now if I write the converse, so now remember the converse is if P, then Q. Oops, sorry, it's not, I lied. Let me rewrite that and restate it. This is P, then Q. I got ahead of myself. This is Q, then P. So I want to say it backwards. So now I'm going to say if two lines are perpendicular, so if two lines are perpendicular, then they intersect to form a right angle. So you always want to make sure when you say if, don't go if they, because you haven't introduced the two lines yet. So you want to make sure I know what you're talking about. If two lines are perpendicular. Okay, now, since both of these statements are true, because if two lines intersect to form a right angle, then they are perpendicular, that's true. And if two lines are perpendicular, then they intersect to form a right angle. That's true. So this would be a biconditional statement where I would say, two lines intersect to form a right angle if and only if they are perpendicular lines. So that's how you would state your biconditional statement. All right. Now, the next thing we're going to look at, these are called truth tables. Truth tables are when you have a conjunction or a disjunction or a negation. Okay, negation, remember, is your squiggly. A conjunction is using the word and, okay, just like in English, like a compound statement, conjunction, I'm going to do this and I'm going to do this. A disjunction is using the word or. I'm going to do this or I'm going to do that. I'm going to go hang out with my friends or I'm going to do my homework. Or you could say, I'm going to go hang out with my friends and I'm going to do my homework. So what that looks like is when you have all these, it kind of helps you create your to find out if what you're saying is true or false. So for example, if P is true, then not P is false. If your hypothesis is false, then not P is true. And these tables are kind of like a key, like a formula. So if these things are happening, these are the only outcomes. So for a conjunction, so if I'm going to go to my friend's house and I'm going to do my homework, this is my and table. So when you see and, you know this is what's happening. So if I go to my friend's house and I do my homework, then the outcome is always true. If I go to my friend's house and I do my homework, but I really didn't do my homework, then that was a lie. That was a false statement. Or what if I go to my friend's house and I do my homework, but I really didn't go to my friend's house? Then I just lied again. That's false. And if I go to my friend's house and I do my homework, but I didn't go to my friend's house and I didn't do my homework, it's false. So the only time you can get a true value out of your statement is when both parts of your statement are true. Now, when you use the word or in your statements, so if I go to my friend's house, or I go to my friend's house, or I do my homework, well, if both of them are true, then it's still true. And notice when it's and, when it's conjunction, it looks like a capital A, but without the bar. So or is just the upside down. It's just B. It's just the opposite. Now, I go to my friend's house or I do my homework, but I didn't do my homework, but I did go to my friend's house. Since I had a choice, it's still true because part of my statement was true. If I really didn't go to my friend's house, but I still did my homework, but I had a choice, it's still true because part of my statement was true. And if I didn't do my homework, or if I didn't go to my friend's house, or I didn't do my homework, it's false. So you didn't do either one of the things you said you were going to do. So it's a false statement. So what we're going to do is I'm just going to do a couple with you on here, and then we'll do more together in class. All right. So what we're going to do is we're going to construct the table. So what you do is every part of your statement has to have, like, there's a P. Since there is a not R, we need an R, and then we need the not R. The last column will always be what you're trying to state. Okay? You're always going to go true, true, false, false. And then the second column is opposite, true, false, true, false. So you alternate. So it's always true, true, false, false, then true, false, true, false. Not R is the opposite of R. So if R is true, then not R is false, and so on. And now you're going to compare P or not R. So remember, when it's or, only one part has to be true. So this is what I always do. I always take and I cover up, I always cover up the column I don't need. Since I'm only comparing P and not R, then I don't need this column here in the center. So there we go. I don't need that column. So I'm just going to compare these. So true or false is true because I had a choice. True or true, false or false is false. False or true is true. Okay, so that's how those are going to work. I'm going to do one more with you, and then we're going to stop and we'll do some more in class. So please make sure that you hang on to these. So if I have a not P, I have to have a P, and then a Q, and then a not P. I always take care of the positives, your P's, your Q's, your R's, and then I take care of the nots. And then the last column is not P and Q. So your first column is always true, true, false, false. The next one is true, false, true, false. Because what you're trying to do is you're trying to come up with all your possible combinations. Kind of like if you had two coins and you flipped it, you can get two heads, you can get a head and a tail, or you can get a tail and a head, or you can get two tails. So you want all your possible combinations. Your not P is the opposite of P. Well, if P is true, true, false, false, then this is false, false, true, true. Now you want to compare this column to this one. So I no longer need this column. So I'm using and. So remember, with and, you're saying you're going to do both parts. So false and true is false. If one part's false, it's all false. False and false is false. True and true is true. True and false is false. So I'm gonna let that sink in a little bit, and then we'll look at some more of these in class.